And maybe we should just quick highlight, even though you already did it, I think repetition is maybe good. Highlight the difference between the means and the proportions. So every worksheet, every problem we do now, it's going to say mean. But yes, Laura, let's do that. Let's highlight, how do we know it's a mean? You know, what are the clues and what's the information we have? So I'm going to go to, first, the first thing to note is with proportions, we found critical Z values, and we used the normal calculator just like in chapter 7. With means, we need critical T values. And this is a whole new distribution. I'm sure you talked about a little bit in your notes. It's the student's T distribution. It's very similar to the normal distribution. The one difference is that instead of using a mean and a standard deviation to calculate T values, also known as X values, or areas, we use degrees of freedom. And this is kind of a complicated concept, degrees of freedom. So we just tell you, use the sample size -1. That's it. And that's how you find your critical T value. And then where you find it is the T calculator. So it's under the same menu, stats, calculators, and then instead of normal, you're picking T. And then because we're doing a confidence interval, we need 2 critical values. So you use the between formula or the between menu and put in the confidence level. And that's how you get those critical T values. So it's a new distribution. It's called the student's T distribution. It has the same mean as a normal distribution, but a standard normal distribution, but we don't know the standard deviation. That's the problem. So we use this one. Okay, so what's different? Well, the formula, surprise, it's different, and yet it's the difference. The different parts in these formulas is what was different from chapter 8. Remember when we found the spread, which was the standard error of the X bar, we used this formula right here, S divided by the square root of N. So that's one piece that's different. Here's where we use the formula in chapter 8 for the spread, standard error of the P hat, square root of P hat times Q hat divided by N. So that's one piece that's different. The other obvious piece is the X bar and the P hat, right? One of them's a sample mean, one of them's a sample proportion. So for how we found P hat in our problems is either it was handed to us or we calculated it from X divided by N. The new thing with means is that you will be given data sets and you will calculate X bar from the data set, just like you did back in chapter 3. Otherwise, we'll just say, here's the sample mean. And then we already talked about how the T critical value is different. So in some ways, these formulas are exactly the same. It's the point estimate plus or minus the margin of error. Point estimates are different, P hats, X bars. The margin of errors are calculated different. We have the different spread formulas that you already knew about, and then we have different critical values, Z versus T. But otherwise, all the rest of the confidence interval information that you know from 9.1 is the same. The point estimate's the middle. The distance between the point estimate and the upper limit and the point estimate and the lower limit is equal, and that's the margin of error. And then we still have these same verify conditions to look at, condition 1, 2, and 3 that you had from chapter 8. So with that said, we're going to use this information and what we know from 9.1 to run through this 9.2 worksheet number 1. Let me talk through the first problem, question A. And then I'll let you do the rest of this first page. Well, we'll see. We'll see how you can do. We'll see how you feel about that. Okay, so for each of the following situations, create a scaled labeled number line graph that includes and labels the point estimate, state the interval and interval notation. Okay, so this is doing what I talked about. You've got the point estimate in the center. Shoop. And then you've got your margin of error that you add to it to get the upper limit. Let's see if I can make sure I do the upper limit. And you've got the margin of error that you subtract from it to get the lower limit. And that margin of error is the same distance between each of these. So your job is to figure out what's the point estimate and what's the margin of error, or are we given limits or what? Now I'm noticing that this first one, so the first one says the average American household. Ooh, this is a special word. What does this word tell us?
The mean.
Good. We're going to be working with a mean here, meaning the statistic of interest will be an X bar. Okay, so the mean American household, the average American household uses between. Hey, do you remember when we interpreted the confidence interval? We used the word between. 6 and 10 rolls of toilet paper per month. Ooh, nice. Okay. So what are these numbers? Are these X bars? Are these margins of errors? Are they point estimates? Are they limits? What are they?
Point estimate is 6 and 10.
Are they is 6 the lower limit and 10 the upper limit?
Oh yeah. Yep. Yeah.
How do we know that? What is the main thing that tells us 6 is a lower limit, 10 is an upper limit?
Well, it says between.
Between, yeah.
That's it. That's the word. So the X bar is between those two things. And here's the thing important note to make. There is only one X bar. There are always 2 limits in the confidence interval. So number line, smallest number comes first, largest number comes second. Now, why did I leave this middle one blank?
Because it's X. We have a formula to solve that. That's the mean. X bar.
That's the X bar. Good. That's where the point estimate is. It's in the middle. And yes.
Yes, so that middle one is the point estimate. And point estimate and X bar are the same.
Yes. Well,
Okay.
We should be careful. Back in 9-1, the point estimate was p hat.
Oh.
So point estimate just means the sample, the statistic, meaning the thing we calculated from the sample. So it could be an X bar, it could be a p hat, it could be a standard deviation. There's a bunch of different statistics we could calculate. When we're talking about a mean, then it's definitely an X bar. It's a general term, kind of like how average could be mean, median, or mode, or spread could be standard deviation, IQR, or range, or variance. Okay, so you said you had a formula to calculate X bar. What is it?
Well, you have to add the upper limit and the lower limit and divide by 2.
Nailed it.
So 6 plus 10 is 16, divided by 2 is 8. So X bar is, or the mean is 8.
Good. Now, that formula works if you know the lower limit and the upper limit.
For that, can't you just like count what's in the middle, or you don't want us to do that?
Yeah, okay. You can do that. Yep, you can do that. Definitely. Yes, definitely. How you like, so sometimes it might be kind of difficult to count what's in the middle, like if the numbers are kind of gross. You know, if it's like 6.795 and then the upper one is 10.84376, like that's going to be a challenge to count. But in this case, you definitely could have. But sometimes you can't find the X bar. If you don't know the upper and lower limits, this formula is useless. But maybe that goes without saying. Okay, how would we write this in interval notation? This is what we mean by interval notation.
So it would be 6, comma 10. Because the lower limit's on the left and the upper limit's on the right.
Now, can you all tell me what that 6, comma 10 means? Maybe you can.
That's what we plug into that one sentence about like the, I don't know, the confidence levels are in between that and whatever.
Yes. Which really, the sentence is above us, right? You started with the sentence. So this is telling us that the true mean number of toilet paper rolls used per month by an American household is somewhere between 6 and 10. Okay. I'm going to give you 5 minutes to do B and then 2 A and B. And notice A and B, well, I'm curious how you do with A and B. So let me give you 5 minutes to do that. Unless does everyone feel pretty confident about what happened with A? Okay. All right. Set a timer for 5 minutes. That was 5 minutes. Is that enough time?
Yep, I'm ready.
I'm ready to.
Okay. So what's the 82?
The point estimate.
Good, the X bar. Now, man, when I read this, when I look back here again about average American household and then average American adult, I don't know that that's really a clue that this 82 is an X bar. What really separates this from a p hat is the units. And that's a p hats don't have units. They're percentages. So that's a clue. All right, what's the 15?
That's the give or take. So that's your plus or minus from your 82.
That's the distance between the 82 and the upper limit and the 82 and the lower limit. Yes, so that's the margin of error.
Margin.
Excellent.
There it is.
Nice. Yeah, the words aren't that important on that one. So we'll call that ME. Actually, you know what I think has been what the book uses, or what the notes, what Alana's notes use, is E. Maybe Cindy even used this E. Okay, so what, 97 and 67.
So margin of error is basically like spread or standard deviation. They meant.
Yeah, that's kind of a decent way to think about it. Yeah, it's like
Okay.
right. So the point estimate is the mean, and then the margin of error is the standard deviation, about one standard deviation around that mean, kind of. It's kind of not, because it's not spread. It's spread times the critical value. And so it's the width, like how far apart these two numbers are, like how big this number line is, depends on how confident we want to be that the number line itself contains the parameter, the population value. So it's a little different concept than what we did back in what I think chapter 3 is, where you first did the normal curve and all that. But it functions similarly. Okay. So here we're just supposed to put these on the number line, create a number line. So it's a little weird because it's just like, do this, figure out where this thing is. It's like right here, and then say whether it's inside or outside the number line. Does it say to do the point estimate? It doesn't, but I think we're
outside, Eric, because it starts at 181.35 and the number is 181. So that's outside, right?
Yep.
See, I could have
1.35 is bigger than 0. Good, thank you. Do we want to bother with the point estimate? It's 210.15. It doesn't particularly matter. It's not. Yeah. Okay, so then you did negative 0.56 and 1.84, and zeros in here somewhere. So inside. The reason we ask you to think about this is because this is the support the claim question. So I have to figure out where is the claim relative to the interval, and then what is the claim? That the true proportion or the true mean or the population mean is above, equal to, or below a particular number. Okay, how are you on finding critical values in StatCrunch?
I have those done as well.
Okay, how about the rest of y'all?
I didn't get that far.
Okay. I'll give you 3 minutes to mess with that. I just say 3. Do you need to see where to find the stuff in StatCrunch?
I would love a refresher.
Let's refresh. So these and these you have less to enter. Is that true? Maybe not, than the normal, because the normal, when we got in there, you had to enter the 0 and the 1 for mean and standard deviation, but really it was already there. So I did that fast. Ooh, I need to calm down. And I'm brewing coffee, so you're gonna have to tell me to calm down, I'm sure, in a minute. So it's stat calculators in T. And you get this nice little T calculator. And the DF is degrees of freedom.
But you have to do the n-1 is the DF.
That's it.
So it would be 15 for the first one.
You got to be between
0.80.
Good.
And we would write that as the plus or minus, right?
Right. Because you're asked to find both of them, and they are symmetrical, just like the Z critical values. Did it say what to round to? Doesn't say what to round to. It doesn't really matter, but we tended to do 3 decimal places with the Z critical scores. Okay. Is that good? So the 0 after the 8 doesn't add any information. Just like the 0 before the 8 doesn't add any information, before the decimal. That's why I didn't put it. In fact, you can put a bunch of zeros here if you want, and they're all just 0. Where it does matter is if it's between the decimal place and the number. Like if this had been 8%, that would get us something quite different. Excuse me, yawns. I forgot to set a timer. Set a timer for 2 minutes. You probably don't need 2 minutes, do you?
I'm ready.
So plus or minus 1.701. And plus or minus 2.943, right? Anyone?
You're in the standard. Why didn't I get the same ones? I'm confused.
Okay,
You
so
didn't use the DF.
yeah, you didn't use the DF on C.
Did I not change it? You sure?
Well, it's
29
48.
minus- Oh, see?
It's 48 on that one, and it should be 47.
Did I put 48? Sorry.
That coffee.
I know I need that coffee.
I'm drinking my Big B. I understand.
I did a 8-cup freshly ground. I don't know what my grounds are, but I freshly ground them. I don't know if it makes any difference, but it certainly makes you feel bourgeoisie or whatever. Oh boy, fourth, nice, y'all. Drink water too. Coffee's that diuretic. Okay. Awesome. So now we're just going to calculate a bunch of confidence intervals. So let me show you that menu as a reminder. Stat, T-stats, and the reason it's T-stats is because we use critical T values. One sample, and we don't have data here, right? We have an X bar and an S. So we're going to do with summary. Now notice what StatCrunch wants. They want the X, okay. They want the X bar, they want the S, and they want the sample size. Oh, I hear the beeping of my coffee machine. So 98.2, 4.25, sample size of 15. And then we are doing confidence intervals. So you have to perform the confidence interval for the mean. We'll be doing hypothesis testing in chapter 10. And put in the C level. If we want, we can have, just like with the p-hats, we could show the critical value in our little table if we wanted to by clicking that button. I hope I didn't do that too fast. And here is our interval. And let's just do, oh wait, what does it say? Round to 3 decimal places where needed. I believe this is like the temperature, the body temperature of an individual. Doesn't that
Oh,
look about-
confidence interval is always the, like, in the parentheses. Okay.
Yes. That's the upper limit, lower limit. That's what we mean. The between thing. So that's one of them. You repeat that a couple more times, 3 more times here. Or 3, I can't count. 2 more times. Now, do you all know how to calculate the margin of error from a confidence interval or using the standard error and the critical T value? Because there's 2 ways we can calculate this. Here, let me go to the reference sheet. One way to calculate the margin of error is this. Critical value times the standard error. Notice we have that in our table. Critical value, standard error. The other way, I'll just put it on here, is if we know the confidence interval, it's the upper limit minus the lower limit divided by 2. Now that's a scary one because it's really, really similar to how you find the point estimate, right? What's the one difference?
Subtraction instead of add.
Yes. So that's easy to mess up. So it might easy to mix the two, kind of like with the upper and lower fences. Remember that from eons ago? So you can decide how you want to find the margin of error, either use the confidence interval or do the multiplication. So let me give you, like, is 5 minutes too much time? We'll do 5 minutes. And if you get done early with this, let me know. Set a timer, 5 minutes. You need to go potty. Come on. Let's go potty. Come on. How do we do, y'all?
I'm doing all right. I think I did my margin of error wrong. I added instead of subtracted, so I should be doing the upper limit minus the lower limit divided by 2. So I was just fixing that. Other than
Okay.
that,
I'll write in a couple answers then, if you all are comfortable with that, and we can compare and see who did it right.
Yeah,
Me
I'm
or
ready.
you. This level of the sea level is going to be so easy to forget on these. I was about to do it just now.
Eric, you multiply the critical value and the standard error.
I did. Did we get the same number?
I thought we divided.
Well, so if you're using the critical value and the standard error, you multiply them.
Okay, that's what I did wrong.
If you're using the interval itself, 1784.912 minus 1795.088 divided by 2. Oops, I subtracted them in the wrong direction. That's okay. I just make this positive and we're good. Anyone need to see anything done or have any explanations? I was just mashing numbers, mindlessly mashing. And I think I got them right, but I could be wrong too. So feel free to challenge me.
I got all the same ones as you.
Nice. Then we have to be right.
I put in the same numbers. I just, divided instead of multiplied. So
That'll do it. Okay, good. This isn't like a type of question really. Well, the questions aren't going to look like this, but this is helping us get comfortable with that confidence interval. Okay, so just a few left here. One more confidence interval, and then here, notice you're computing the margin of error, and we give you the standard deviation in the C level. Does anyone know how to calculate the margin of error in these cases? Do you know what you're going to have to do?
Is that the T with the alpha divided by 2 multiplied by S divided by N squared?
Square root of it. Yeah, right.
Oh my God. Yeah, that one.
Yes. So you're going to have to find critical T values. It looks like in some cases you're going to have to do this calculation. And in one case, we gave you that thing. All right, so let me give you some time then. It sounds like you can do it. Let me give you 5 minutes because
can you go back to the equation?
Oh, yes. So either it's the critical value times the standard error, if we know it, or it's the critical value times how we calculate the standard error, S divided by the square root of N. Which, by the way, is what Reagan, you and I were doing. We were taking the critical value and multiplying it times the standard error, because StatCrunch spit that out for us. Now we don't know the critical value, so we're going to have to calculate that just like you did somewhere here. Don't forget to do 5. Just write in a confidence interval, just like it's a contextual one, just like above. So let me stop scrolling around. If you want me to leave it on the screen, and I'll give you 5 minutes to work on that. So that time for 5 minutes. Of course, we can extend it if we need to. That was 5 minutes. You'll need more time? How does that look for y'all?
Okay, so for the bottom one, I did, how on earth did I do this? Oh, I did the 2.684 and then I multiplied it by the square root of n to get s. Is that how that works?
You could
'Cause it's like-
definitely do that.
And then
Yep.
I just did that and then I just did what I always do.
Yep, that's a reasonable thing. You should get the same answer as this, because what I did is calculated the critical value. You didn't need S though. Because you're given the standard error, which is this whole thing. So you don't,
Oh, so I didn't.
I mean, it's fine if
I
you
did
did
too
S
much.
over the square root of n again.
I think that's what I did, yeah.
You should have
Yeah,
gotten
that is what I did. So I
2.684.
just did an extra step for no reason. Got it.
Go ahead, Laura, what were you gonna say?
I have to see the whole problem and all of the equations that I'm using to get like NS.
So like this?
Yep, I have that one. So I have A. So B, I can't figure out where you got that 14.
Ah, that's why I put it in red. Remember, it's the square root of n. You're given degrees of freedom. So Degrees of freedom is n minus 1. If we want to solve that for n, we'd add 1 to both sides, and you get n is the degrees of freedom plus 1.
So it would be n equals 14.
That's it.
Oh my God.
That's going to happen here and there. There's going to be little problems like that. Yeah.
And then can you show me exactly what you did for C as well, please?
So,
Because I want to make sure I have mine set up. I didn't do all of the work yet. I just had to make sure I have all the right answers there first.
right. And then the rest is just calculator typing. Yeah. So for this one, I just used this piece of the formula where like we don't have to know the standard error formula because it's been given to us. So this is just the critical t value that I found from StatCrunch times the standard error of the x bars. Does that make sense?
Yeah, that makes sense. Okay.
So you were just handed this, whereas before we had to calculate it.
That's where I'm getting thrown off, is I'm getting different numbers in different spots and it's making me think too hard. So that's all.
That's like the whole point of education, is make you think hard. Love it. Success. You're succeeding.
It's too early in the morning for this, Eric.
It's not morning anymore by 1 minute.
It's still morning for me until about 3.
Yeah, unless you work the night shift, and then I hear you. Okay, so if we want to get if you want me to go ahead and type in all the numbers and get the calculator result, this is what I get from my calculator. How about I do it in a different color, like pink, because everybody loves pink. 2.2465 for that one. $27.8626 for that one because of the 8 after the 5. And then 4.5778 for that one.
Can you go over how you got the 2.4385 for B? Because for some reason I got a little bit different answer. I don't know.
I probably did it wrong. That's probably a good chance. I did 13 for degrees of freedom, and then I did 0.95. And yep, whatever I did was wrong. So, man, I don't know. Did I leave a 99? No. I have a 90 in there? No. I swear, I think I just wrote it down wrong. Okay, so thank you, Reagan. Great catch. It should be 2.1604. That's what you had, right?
Yes, that is what I had. And then the answer is 24.7123.
Nice. Okay, does everyone feel good? Okay, so what I want to do, this is practicing all of the little like mechanics of a confidence interval, right? Like the critical value, kind of how to think about it conceptually as this range of numbers, the margin of error, some of the wording that you can get to for these. Now let's go to the final exam type questions. So I'm going to skip to the worksheet number 3. We currently have worksheet number 2 as an option to turn in for 133, and we'll see kind of where we land today if we want to continue to do that. Maybe we'll make that decision on Monday. if we feel like we need a bunch more practice on this. And I want to skip to this question. All right, so this is page 665, and I just want to throw you to the wolves and have you do the whole thing start to finish. Here's a prompt. Make sure we can construct an interval, do the construction, interpret what you got, and evaluate a claim. This is the thing I want you to be able to do on the final exam. So first off, we have a data set. Please don't type that data set. If I can figure out how to turn this off. Did I just do it? I did. I'm going to figure out copy link where this is, StatCrunch. In fact, I'm going to toss it into chat. You should be able to click that link in the chat and it should open in StatCrunch this data set. So let me know if you didn't get it. Okay. Nice. So now let me remind you, when it says verify the conditions are met, here's the 3 conditions. Same ones from chapter 8. Same thing with the independence. Is the sample size large enough? Or is there a graph that shows normal with no outliers? Anyone remember what this graph is called?
Linear something.
Nice. Okay, I like it.
One
No,
word.
that's not it. Good guess. It's 7.3. I'm gonna go all the way back there. It was that short little section that was like 1 page. Oops, there I jumped to the hypothesis testing. It's the normal probability plot. Do you remember how to read it? There was a sentence I gave you that you were to write every single time. And I was more interested in you being able to write the sentence than being able to read it 100% correctly. This.
The normal probability plot is approximately linear.
Nailed it, Reagan. Yes. So if you're forgetting, it's on page 189. This is essentially the sentence you're reading. We want the normal probability plot to be approximately linear. If that's true, then the population is normal. And if the population is normal, then it doesn't matter what size sample we draw from it. The sample distribution of sample means will also be normal. So there are not 30 data values in this data set. There are 27. So n is too small, but this tells us the normal probability applies approximately linear, thus the population is normal. Okay. Excuse me. Let me give you 5 minutes and let's see if you can get A and B in 5 minutes. So that's the goal, just those 2. Just a reminder, this is T-stats, 1 sample with data, and you have to select the column, and then everything else is essentially the same here. You just don't have an X bar. The X bars and things are showing up in the table. Okay, so let me be quiet and see what you can do and refill my cup. Set a timer, 5 minutes, go. Okay, that was 5 minutes. How are we doing?
Okay, so we go to the one sample T summary. Okay, and then, so I get the sample mean, you do 27. And then for standard deviation, how do I even?
Wait,
That's
wait,
right.
did you do with summary?
Oh, let me see. So stat. And then T stats with summary. Yeah.
Do it with data, because this
Oh,
is a
with
data set.
data. That's where I messed up.
If you can do the summary statistics like we did back in chapter 3, and you can get the sample mean and standard deviation from the data, you can do that if you want. That's fine.
So then you just have to put the 0.9 in and that's all.
That's it. That's it. Yeah.
Okay.
No, there's compute. I need a second monitor. So with you, Laura. I'll quick write in these conditions. I'm thinking they were pretty straightforward. Was everyone okay with the conditions?
So mine is saying you must select at least one values for select columns where.
The very
Oh,
top, remember that mess? Yeah. I know Cindy and I have been telling you that we rarely give you the population, the number for the population, but it feels like every single problem now has the number in it. So maybe Alana changed that. Does that look like what y'all wrote for normal probability plot or for the conditions? Nice. Okay. So for this is what Cindy and I were, or what Cindy was asking me about yesterday. Like, what do I really want for the formula part? And we had agreed we would just go with this part so that you don't have to go try and calculate the sample standard deviation. Just as a reminder, if we wanted the sample standard deviation, we'd go to summary stats columns and we'd select mean and standard deviation. And there you get the sample mean and the sample standard deviation if you want it. StatCrunch will not give you the standard deviation when you calculate the confidence interval. It just gives you the standard error. Now the standard error contains the standard deviation, and we could solve for it if we wanted to using the square root of n times the standard error. But that's just like kind of an unnecessary step. So for showing the formula you use, what I'd like to see is this. Okay, so that you know it's the X bar plus the critical value times the standard error of the sample means. And then for the substitution part, I just want to see that you identify the sample mean. which StatCrunch gives you. You identify the standard error. And you identify the T critical values. Does that make sense, y'all?
Yes, I am double checking myself, so please don't move on yet.
Good. I will not. I haven't even written the answer down. Now, my morning class or my in-person class was writing these numbers in this form. So they would rewrite it here. I don't need to see that. Part of the reason I don't encourage that is because then students often want to go ahead and put that into a calculator and try to calculate it from this, which is totally doable. It's fraught with mistakes because there's two calculations here. I just want you to write down the result. And that's this confidence interval. And I suppose we're supposed to include units. And I don't know what they are because I didn't read the context at all. What is this? Oh, this is money. This is credit card debt. Ouch, $12,000.
So we
Talk to me.
don't want to just put down the conference interval. We want to put down like all that stuff that you did over here. I don't even know like where those numbers came from. They came from like what StatCrunch was doing.
Yes.
Okay.
They're just the numbers from StatCrunch. So sample mean is the X bar, which is the point estimate in the formula. The SEX bar is the standard error of the sample means. And then the T critical value is the critical T value.
The SEX is the standard error
Of
Okay,
the
yeah,
X
right.
bars, yes.
Okay.
Now make sure you say SEX bar so it doesn't sound like that other word. Yikes.
Yeah.
No, it doesn't matter at all. And I should be picky on the units. I should. Did you read the context? This is Capital One credit card customers. This is one credit card. I don't know if you're like me. I've got like 10 credit cards, which is probably really bad. But just for that one credit card, this is the amount of debt these customers are carrying. And then if you're taking the 130 class, you're probably paying 29% APR on that debt. So that debt is growing each month. Ew, I hate to think about it. Okay, is everyone happy? Does anyone have any questions? Have you checked your answers and feel good that you were
I have a
able
question.
Please.
So since we're talking about money here, should we still leave those 3 after the decimal or no?
Good point. It would make sense to round these to 2 decimal. It would make more sense to round these to 2 decimal places. Lots of times money does, when it's electronic, we do go more decimal places out. But credit cards don't, right? They don't. I don't know if you all have credit cards.
Just keep adding interest. That's what they do.
Yes, when you're adding interest and then they round at some point. And in the fine print, they'll say somewhere how they round.
Yeah, and I think they always round up.
Well, I do know there was a case a while ago where someone sued Verizon for doing that.
Yes.
Yeah. And they won. Did I
Yeah,
say that to you all?
They should have. Verizon and Comcast, they give you extra. They charge you extra if you go and pay it in person too.
Of course.
For them to process your payment. It's ridiculous. But anyways, off topic.
You have to pay the person to process it, right? I mean, that makes sense, doesn't it?
Not really. They're already getting paid by the hour. Come on now.
Well, it's when their profits are in the like billions, right? Like, have you seen their advertisements? We're going to dump $1 billion into doing something. And it's like, yeah, that's probably 1% of your profits.
Right.
Okay. So, what, 5 minutes for C and D or not so much? 3 minutes, 5 minutes? 5 minutes. I need to let you think. Set a timer for 5 minutes for C and D.
I put mine in the chat. Unsure if anybody's looked at it or not, but that's my guess.
Nice. Crushing it. Okay. So, what'd you get for D?
It contradicts because the 18,000 is within the interval. I mean, by $89, but
Still contradicts. It
yep.
says less than. It says less than this, and while most of the values are less than that, there are values that are higher. Definitely. Good. Oh, how do you all feel?
You said support. No, it's contradict.
I just was reading the within part. Good. Thank you. Thank you. You're like, come on, guy. Ugh.
Come on, Eric, get it together. Drink your coffee and let's do this.
I'm on cup 3. I probably need to get to the Misty levels, and then maybe I'll be okay. Okay, good.
So Eric, for it
Talk
to
to me.
support, it would have to say like exactly what the interval is.
To support a less than claim, the 18,000 would have to be, the number would have to be above the upper limit.
Oh, okay, okay. And then for it to be more than, it would be have to be less than the lower limit. Got it. That makes more sense.
And equal to has to be within. So here's the thing, if it's within the interval and our claim is either less than or greater than, it's going to contradict. So the only time within the interval can support is if it's an equal to statement. You know, someone's claiming the average or the population mean is blank. If it's within, they're good. It's within the realm of possibility. You know, it's super fun about today. I know it's contentious and there's lots of hate and whatever, but today is a population day. Like that's literally what's happening all over the country. We are tabulating a population value and we're tabulating a P. And for months now, we've been running samples of P hats to predict what today's results will be, or the results in the next couple of weeks, you know, however long it takes to count or the courts to decide that it was legitimate. But election day, it's a population day. It's like statisticians' like favorite day. Cool. How about we jump back now to question 3. And maybe you can just go from start to finish, because what we've given you here is an output with a very strategic omission. The sample mean, bum, bum, bum. Anyone know how to find the sample mean from the confidence interval? Let me speak in more general terms. Does anyone know how to find the point estimate from the confidence interval?
The upper minus the low, or the upper, is it something divided by 2?
Nailed it.
remember
It's
if
either
it's not-
plus or minus. Yeah,
I think
which one
it's
is it?
Subtract.
Subtract is going to get you the distance between the point estimate and the limits. So you want to add, because you're looking at where's the middle. The point estimate is the exact center of the limits, meaning it's the mean of the limits. That's literally what you're calculating. You have 2 numbers dividing by 2, adding together the 2 data values, divide by 2, and you get the point estimate. Does that help us find the sample mean?
Yes. No.
Mark, which one is it?
Question mark.
Okay, that's okay. What does point estimate mean? What is it?
I'm looking through my paper.
Can wait.
because the of the confidence levels.
No, what's the definition of point estimate? What is it?
Oh,
Generally speaking, it refers to what?
oh my God, it's on the tip of my tongue now. Hold on, let me flip through my 80,000 papers I have here.
We'll give you a hint. It starts with an S. It's part of the title of this class. Center is true. Yes, it's definitely the center. Does that help us with whether or not the sample mean has anything to do with the point estimate?
Is it statistic?
Yes. And remember, statistics come from samples.
Oh, sample. Oh, geez.
It's okay. It's okay. Don't be upset. Yeah. So sample mean is an X bar, which is a point estimate for a population mean. So yeah, this is how you're going to find the sample mean. That's how to do it. I think that's the only one that might super mess you up on here, because here it says compute the point estimate for mu. Oh, and then we tell you using the interval. All right, so this question is a similar question to what you just did, except that we've given you almost everything. Let's do. How much time do you think you need to do the entire question, parts A through J? Let's do 5 minutes, and I'll see where you're at. How about that? And I'll see if I can't get to cup 4. Set a timer for 5 minutes.
Okay, where are we at?
I'm just finishing up C.
Let's do 5 more minutes then. Set a timer for 5 minutes.
Okay. Um. That was another 5 minutes. How we doing? Any of these questions you all getting stumped on? Okay. Shall I let you just keep going? Well, maybe there is one question or two questions we haven't done. It's these two, but I feel like you can do them. You already did this question in the first worksheet. And this question, you already did two in the first worksheet. It just didn't look like this. So are there any of these that, should I just leave you alone? Let you keep working?
Can we just go over really quick to check our answers?
Sure.
Because I just
What'd
want
you
to make
say
sure
for
I'm
B?
on the right path.
Yeah. What'd you say for
Yeah,
B?
that's what I was gonna say.
So which ones should we check? I think you all got C without a problem. That's my thought. As long as you used 50 and 6.5 for this and 50 greater than 30 for this, I bet you're good. Did you find the confidence level? Dun, 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 dun. Notice the language here. It's what we talked about on Monday. It says 98% confidence interval. So whenever we put those three things together, the percentage means the confidence level. Did you all find alpha? Here it is. What am I doing? I want to go to calculators. Did you get the critical values using the degrees of freedom and the confidence level? Oops, there, I'm sorry, I wasn't watching the chat. Let's see, what'd you say? Nice, Nicole, good. Oops, we need a between here, not a right down. Oops, we need an 8. There's your critical values. Is that what you had? Did you get a point estimate of whatever this divided by the sum of those two divided by 2 is equal to? Oops, I clicked edge. No, 2.9999999. So 102.200. What is this? Oh, minutes. This is minutes. Did you find the standard error on the page on the printout? This literally says standard error. Of course, you got to know that that's how StatCrunch lists it, but I think you all know that. Did you remember that the margin of error is the critical value times the standard error? And you know both of these numbers. This number is here. This number is what you calculated here. Did you say the thing that you all are really good at? And do you know how many minutes are 1.5 hours? Did that help you check your answers? Nice. J is a support, by the way. 1.5 hours is 90 minutes. 90 is below 97. So the mean length of a movie is 7 minutes longer than 90 minutes. And apparently that Avatar movie that's coming out is going to be like a 4-hour movie. I don't know. I saw a headline that's like, you're going to be in the theater for a really long time.
So for I, you just have to go back and look at the lower and the upper. Okay,
We
I
are
missed that.
98% confident that the true population mean length is between this many minutes and this many minutes. Nice.
And then
Yep.
for H, we do 2.4049 times 102.2.
Nailed it. Yep. That's it. Wait, what did you say did you say 2.0995626 or whatever this is rounded?
For which one?
For
H.
number H? You were using
You
this number, right?
Oh, got it. Yeah, standard error times what we got
one.
for E.
Yes. Good.
Yeah.
Someone said you didn't get what? Talk to me. Someone said you didn't get something, and we were chatting. I didn't know who it was. Speak. Anyone have any questions about any of these? I kind of sort of said the answers. Cindy and I are getting worried that I don't think it's you all as a group, that too many people are just watching the movies to write down the answers. And that's a waste of time. I know you all are not doing that, but so that's why I'm kind of purposefully not writing down all the answers now to help you work through it. That's the value.
I'm
Go ahead,
trying to find where I figure out the alpha. I know there's a formula for it somewheres.
I would love to write it down. It's the complement of the sea level. So
that's what it is. I keep wanting to plus, but it's that minus. Okay.
Kayla, that's not a bad idea with standard error because there's so many numbers in there. You could round it. So you could use what, 2.100. That's rounding to 4 decimal. No, I guess if we're going to use 4 decimal places, you could round it to 2.0996. If you did 3, it would be 2.1. Or you could use all of them. It doesn't particularly matter. What's most important is that you know how to compute that margin of error. And then on the exam, when you do it, if it's a question like this, make sure you write down the 2 numbers you're using so I can see if it was a rounding mistake, if you get a messed up answer. Okay, what do you all think? Do you think I should demand that you work through this 9-2 worksheet, number 2, and turn it in? How's everyone feeling about my stat lab? Oh, so Reagan, you think I should assign this? Because here's,
I feel like we could probably, unless that we do it on Monday or Cindy goes over it with us tomorrow.
So I think what Cindy's going to do tomorrow is the 9-4 section, which is the end of chapter 9. Okay. All right. So good. I'm going to say you all complete this and we'll go over it on Monday. I think the extra practice is super helpful. Some of these problems aren't as these are decent problems, numbers 1 and 3, but they're not how you're going to be asked these questions on the exam. So I don't know. I hear that. So try that one. And then on Monday, we are going to look at 9-4 and we may have time. So we'll do one of these worksheets and then we're going to do one more big one over them all. That's the chapter 9 review one. And then we'll put chapter 9 to rest. We won't, because it shows up in chapter 11 again. So this is, we still have that good practice. I think maybe what I'd also like everyone to do, and I should ask this at the beginning of class instead of now, is send me an email about how you're feeling on the workload. Is my stat lab becoming too much? Is it getting in the way? Yes. And if it is, I mean, I'll have to talk to Cindy about what she feels about it. I think for now, if you're limited in time, focus on your worksheets and your notes. I know some of the hesitation to, some of my hesitation on things is I know there's a contingent of students that aren't really doing much of anything, or at least that's what it appears to me. And so if I start like reducing the workload, I'm afraid they'll do even less, which isn't helpful for those of you that are doing everything and feeling like it's too much. So I know for 133, I'm happily going to work with you on what's going on with my stat lab. If you're getting super way behind, we'll figure out what we can do to help. And I'm okay doing things on an individual basis as well. But I need to talk to Cindy about what she feels about those things, because I don't want to overstep anything she's doing. My stat lab is a huge portion of your 033 grade, I think, right? Isn't it 25%? And for the 133 grade, it's 10%. And so it's kind of a double whammy. We were going to do quizzes. Remember, we removed the quizzes and just made it my stat lab. So just keep us in the loop and keep practicing. The goal is to learn, not to complete, which is why why we have kind of infinite deadlines, or the ultimate deadline being what, December 11th, I think, is the final deadline for all of the practice work, homework in my stat lab and things. So yes, keep us in the loop of how you're feeling and what we can do to support you, and we can certainly find ways to work through that. Okay, I'm sorry, I'm responding to private chats too here. So I agree that, and then I gotta go because I got my other class. But one of the challenges with my stat lab is the questions are written by people, authors other than the author of these worksheets and the final exam, which I'm pretending to be the author of the final exam, and I might be. And I agree that is challenging. The positive of that is it helps you come at the material from a different direction, and the hope is that it will deepen your understanding. But if it's an overwhelming amount of work to where you're just trying to get the correct answer, that's not what's happening. So I know Cindy will say, focus on the worksheets and the notes. So watch those videos, Cindy's videos, and get those notes filled in so that you have a basis of understanding. You've been exposed to the words and seen some of the practice problems, and then come to these sessions and do the work with us. Don't wait for me to write the answers, and that's going to be your best prep for the final exam, as well as the project. And Cindy and I are definitely going to work with you. It's currently hurting your grade if you don't do it right, but we have controls we can move to make it so that doesn't hurt your grade. Nice. I don't need anyone's proof that you're doing your notes. Maybe I should. Some instructors do require you to spit your notes. I choose not to because I feel like it's an extra step of work, but maybe I should. I don't know. I'm such a bad instructor for students who want to do the bare minimum, right? Like, I'm totally let you do that without your grade being hurt, except that it does hurt your grade. So if you're any of you that are sharing these concerns with me, I'm not worried about you. You're working. So, okay. I've got to go. Great work, you all. Don't be afraid.